All right, Algebra 2, Lesson 16, using Cramer's rule. So far what we've learned, we've talked about systems of linear equations or just systems of equations. And solving by graphing is one method used to solve systems of equations. Cramer's rule is just another way. In fact, by the end of it, you guys will probably have learned, let's see, I've already introduced you to elimination, right? We've talked about elimination, which, multiplying one of them or both of them by a number that's going to allow me to cancel out a variable, right? And then plug that solution in and solve for the other variable. That's elimination. We can also use substitution, right? So there's a lot of different means and methods for solving a system of equations. Cramer's rule is just another one of those. I won't say that it's my favorite. Well, that was loud and annoying, right? So I'm going to move this chair over. All right, using Cramer's rule. So Cramer's rule is just another method, okay? And what it does is it takes our information and it sets it up as a determinant, right? And we've talked about determinants, and we know how to use matrices and find determinants and those types of things. So Cramer's rule system is a method for solving linear equations using determinants. Elimination can be used to solve a general system of linear equations for x and y as shown. And so let me kind of explain what's going on here because it looks really complicated. So because they give it to me algebraically, right? They say if I have an equation ax plus by equals e, right? We could plug in numbers for a, b, and e, right? And then we have another equation, cx plus dy equals f. I would plug in different numbers for c, d, and f. Okay, now here, what they're saying is that I'm going to multiply the top equation by d, and I'm going to multiply the bottom equation by negative b, because what will end up happening is it will eliminate dby right here in the middle. Oh, golly. Totally messed. Here, let's fix that. It will totally eliminate that. Okay? Those things would cancel out. Now, they might do it a little bit differently in here, but whenever I multiply d times all of that, basically distributing d to everything, I get dax plus dby equals de. Down here, I distribute the negative b to everything, so I get negative bcx, negative bdy, negative bf. So far, do you follow me? Okay, all they're doing here is using elimination, and then we add. Okay, so because this cancels out, and both of these terms have an x, the x comes to the outside. Basically, I'm factoring out the x. You follow me so far? So x has been factored out, and I'm left with AD minus or plus a negative BC. Okay, so I've got AD minus BC times x equals DE minus BF. Well, if I'm trying to solve for x, all I have to do is divide by. And so I divide both sides by AD minus BC, giving me x equals this. Looks really complicated, right? And it only really is complicated because we're using letters instead of numbers, and so it's a little harder to mentally comprehend what's happening. If we were using letters, using numbers, it would make a little bit more sense. But essentially, that's what's going on with solving for x by elimination. Now, they use this next set of steps to say, hey, what if I wanted to solve for y? Okay, notice that it's the same equations here. These are the same equations as what we saw right there, but what I'm multiplying is by my x, let's see, I'm multiplying here by this, by the negative of this up here, and by the positive of this down here, trying to get everything to cancel out except y, and it's the same steps as what we used for x. Now, conceivably, if I know x equals DE minus BF over AD minus BC, I could just plug that in for x and solve for y, but I can't do it here because it's this long, complicated algebraic thing. Okay, so that's what they're explaining as elimination, although I think they make it way harder than it needs to be. So what we have is we also have the ability to use determinants. based upon the same equation form. Okay, observe that the denominators of x and y are the same, and that their numerators are different. These same results are found by simplifying the following expression. So they took your same stuff, and we set it up as EF FD, A, B, C, D, and we found a determinant. So that's E times D minus F, or F times, and this should be B here. That's a typo on my part. Okay? And down here you have A, B, C, D. So what they've done, what you do when you use Cramer's rule, is that if I'm trying to solve for x, let's see if I can explain this. When you have, for now, just look at this equation right here. If I'm trying to set this up in Cramer's rule and I want to solve for x, that means I'm going to substitute E here and F here. Okay, so if I bring this down, we should see that E and F where x was. So if I want to solve for x, I substitute my solution for x. Okay, so I get E, B, F, D. Now on the bottom, it's going to stay A, B, C, D. It's going to stay the original four numbers on the left-hand side of the equal sign. All right, and then I find the determinant, and I divide by the determinant. Now, whenever I want to solve for y, I substitute my solution for y. So instead of having B and D, I'm now using E and F for B and D. And I find the determinant, and I divide by the determinant. Now, what you should notice is that the denominator never changes. Cramer's rule for the denominator never changes. Okay, it will be those four numbers on the left-hand side of the equal sign. All right. So, and that's what they explain down here. Note that the elements of the determinants in the denominators are the coefficients of x and y in the given equations. For this reason, this matrix is called the coefficient matrix. That's what they're talking about here and here. Those are the coefficient matrices. The matrices in the numerators are different. In the matrices in the numerators, the constants replace the coefficients of x and y. For x, when we solve for x, and the constants replace the coefficients for y when we solve for y. I know all of this seems really, really complicated. Okay, hopefully I can get into answering some questions where it'll make a little bit more sense. All right, sometimes when you're using Cramer's rule, the determinant of the coefficient matrix is 0, is equal to 0. Okay, meaning I'm getting 0 in my denominator position. If I get 0 for my coefficient or bottom matrix, then my answer is going to be undefined, because can I divide by 0? No. So I get something that's undefined. So down here we see that classification where we're seeing consistent, inconsistent, dependent, and independent. So if my denominator doesn't equal 0, that's what this means right here, the system has exactly one unique solution. Okay? A system that has any number of solutions is consistent. And we remember that the other day when we were talking about graphing equations. Okay? If the denominator does equal 0, but neither of the numerators are 0, that's going to have no solution and is considered inconsistent. Basically, what we're talking about here is we're talking about parallel lines. Okay? That's what we're being given. All right, if the denominator equals 0 and at least one of the numerators is 0, meaning I got 0 divided by 0 on either the x or the y, then it's an infinite number of solutions. It is dependent and consistent. So something along that line. Okay, over here. Okay, that's what I'm looking at. Okay, does this make any sense at all? A little bit? Okay. All right, let's, I got to pull it up here. Let's look at some questions. Let's see, lesson 16. Flew right by it. Actually, you guys have this document, right? You guys can all see this? All right, I'm going to go back and I'm going to work these out on a blank page. Okay, so we start off with negative 3x minus 4y equals 9 with 9x plus 10y equals negative 3. So I'm going to work this first one out for you. Okay, I'm going to explain it as I go, but after this I want you guys to start inputting some information, all right? I want you guys to actually speak up and be able to do some of this. All right, so I'm going to start off by solving for x, okay? Which means what I'm going to do first on the top is I'm going to sub in 9 and negative 3 for my x's. You with me so far? All right, if I want to solve for x, in the numerator, I'm going to substitute for x. Over here, I'm going to get negative 4 and 10. I keep the y's. You still with me? Okay. Now, in the denominator, I keep everything the same as what it should be. Okay, which is negative 3, negative 4, 9, and 10. Okay, that stays exactly as it would. Now, off over here, now I have to find the determinants. So that's 90, let's see, 90 minus 12. Does everybody know where I got 90 minus 12 from?
10 and 9 is negative 3 and negative 4.
Right, so 9 times 10 minus negative 3 times negative 4. Because negative 3 times negative 4 is positive 12, I'm still subtracting that. All right, in the denominator, I've got negative 3 times 10, negative 30, minus negative 36, so I'm going to put positive 36. Okay, then we simplified 90 minus 12. Well, 90 minus 10 is so it should be 78, right? 78. Right. And then negative 30 plus 36 should just be 6, correct? All right. Will that simplify? Should at least simplify down to, 13. Okay, 13. So x equals 13. Okay? What we're getting here is an x and a y value is telling me where these two lines cross at. Right? The next thing I want to do is I want to solve for y. Okay? In solving for y. All right, here's the handy thing about this. Because the determinant, or because this determinant is going to be the same as this, right? I'm still going to get negative 3, negative 4, 9, and 10. I already know the solution. If I've solved it once, I've solved it, right? I know that's going to be 6. Or I'm sorry, yeah, I know it's going to be 6. Do we understand? Because you're just redoing the same work. So up here, all right, we're going to use negative 3 and 9. I'm bringing the x's and I'm putting them back, but now I'm using my solutions for my y. So 9 and negative 3. Well, negative 3 times negative 3 is 9. 9 minus 81, right? Okay, 9 minus 81 should be like negative 72. Negative 72 divided by 6 is negative 12, right? So my coordinates for my solution are 13, negative 12. Do we understand the steps?
Yeah.
I mean, is it a lot of work to get my x and my y? It's I would say it's maybe more work than elimination, maybe. But it's really not terrible, right? Right. The biggest thing that I see people struggle with is whenever I'm trying to solve for x, right, I have to put the solutions in for x instead of the x values. Okay? Whenever I want to solve for y, right, I have to put the solutions of this in for y in there, right? And I put the x's back in their spot. So just being able to know when to put in 9 and negative 3 into those determinants, right, is probably one of the bigger parts. Okay? All right. We're going to skip on your sheet. We're going to skip number 2. Number 2 is it's probably There's like 5 questions that I come across in both Algebra 2 and Geometry that are overly difficult, and this is one of those. So I'm going to skip number 2. All right, go on to number 3. Number 3 says negative 2x plus 2y equals 6. 5x minus 4y equals negative 10. All right, let's start by trying to solve for x. Okay, let's see. Diego, what are going to be my left 2 numbers in my top determinant? 6 and negative 10. Okay? What are going to be my right 2 numbers in that determinant matrix? Allison? No. 2 and negative 4, right? Because I substitute in the solutions for x and I keep the y's. Okay, I don't move the x's to the right. All right, in the bottom, John, what goes down here in the bottom determinant matrix? Negative 2 and 5. All right, what about on the right-hand side? No. 2 and negative 4. See, in the bottom, it stays just like it stays everything normal. Nothing's being swapped out. Okay? All right. All right, help me out here. What's 6 times negative 4? Negative 24 minus what? Minus 20? Minus negative 20. Okay? I've got negative 2 times negative 4. Negative 2 times negative 4. Okay? 5 times 2. Okay? All right, 8 minus 10. Negative 2. Negative 24 minus negative 20. Negative 4, right? Because it's negative 24 plus 20. Negative 4. So I'm left with what? All right. All right. So we're telegraphing what it is that we struggle with, and that's multiplying by negatives and dividing by negatives. Make sure that we don't make quick responses. Okay. All right. Let's come down here a little bit. Okay. We want to solve for y. Do we know what our denominator solution is going to be? What is it going to be? Negative 2. I don't even need to fill it. I don't even need to fill it in. If I've done it right, I don't even need to fill it in. Okay? But what is going to go up here in my y determinant matrix? What goes on the left, Angeli? Okay. Negative 2 and 5. Okay. What goes on the right, Axel? 6 and negative 10. All right, negative 2 times negative 10. Jewel? Negative 2 times negative 10. We're negative 2 times negative 10. 20, good. 20 minus what? 5 times 6? 30. Okay, good. All right, leaving me with 20 minus 30, negative 10. Negative 10 divided by negative 2, 5. All right, so what are my coordinate pairs? 2 and 5. The more you do these, the quicker you can kind of get at it. It's getting easier. All right. If you look at question number 4, It says write the identity matrix IN for matrix C and verify that CI equals I times C equals C. Basically, your solution is what you're multiplying by, because anytime we multiply by the identity matrix, we are getting our original matrix, correct? Do we need to like review that and see how that works out? No. All right. Now, they go on, I mean, 5, 6, 7, 8, 9, 10 are all Cramer's rule questions. Do we feel like we understand this well enough to get started with our homework? Or do I need to work out another one with you? Anybody feel like they need to see another one worked out? Yeah, okay. All right, let's see. Pick one, John. 5, 6, 7, 8, 9, or 10. Just 5? Okay, 5. All right, 5. We've got 7x minus 4y equals 6. 5x minus 3y equals 2. Okay, start with x here. All right, John, you're going to walk me through this. What goes on the left-hand side here if I'm solving for x? 6 and 2. Good. What goes on the right? Good. All right, what goes on the bottom? Okay, what goes on the right? Perfect. So you've got that set up correctly. All right, we've got 6 times negative 3 is negative 18 minus negative 8, right? Okay, on the bottom, 7 times negative 3 is negative 21 minus 5 times negative 4 is negative 20. Okay, up here we have basically negative 18 plus 8, which would be negative 10. And negative 21 plus 20, which is going to be negative 1, which means my answer there is 10. Did you follow that, John?
Yeah.
Okay. Basically, I feel like if you can get it set up, you guys know how to do determinants, or know how to do that. So let's look at y. All right, help me out with the top, John. No, I'm not doing 6 and 2 again. Nope, not doing negative 4, negative 3. Yeah. Right, 7 and 5. Because I'm solving for y, I put the x's back in. Okay? All right, now what goes on the right-hand side? 6 and 2. I'm subbing in my solutions. All right, do I need to do the denominator? No. Okay, negative 1. What's 7 times 2, John? So we're doing 14 minus, what's 5 times 6? 30. Okay, what's 14 minus 30? Negative 16. So my answer is 16. Solution comes out to 10, 16. Okay, can you tell by looking at those numbers why we might not want to solve that one by graphing? Because if we're dealing with 16, we're probably off our standard 10 by 10. Okay, questions? Okay. John, do you feel good enough to go now? Okay.